Hurricanes are powerful and destructive tropical cyclones that can wreak havoc on coastal regions. These massive storm systems are characterized by strong winds, heavy rainfall, and a swirling vortex. But how exactly are hurricanes formed? Understanding their formation process is key to predicting and preparing for these intense weather phenomena. In this article, we will explore the intricate steps involved in the birth of a hurricane, shedding light on the conditions and factors that contribute to their formation. Warm ocean waters. The first ingredient in the formation of a hurricane is warm ocean waters with a temperature of at least 26.5 degrees Celsius, 80 degrees Fahrenheit. These warm waters act as a source of energy, providing the necessary fuel for the storm to develop and intensify. Low atmospheric pressure. In addition to warm waters, hurricanes require an area of low atmospheric pressure. As air rises from the ocean's surface, it creates a void that pulls in more warm air from the surroundings, leading to a continuous cycle of rising air and low pressure. Moisture and humidity. Hurricanes thrive in environments with high levels of moisture and humidity. The warm ocean waters evaporate, saturating the air with water vapor. This moisture-laden air is crucial for the formation of the towering storm clouds that characterize hurricanes. Coriolis effect. The Coriolis effect, caused by the rotation of the Earth, plays a vital role in shaping the structure of hurricanes. As the storm system starts to develop, the rotation of the Earth influences the direction and rotation of the cyclone, giving it its distinct spiral shape. Convergence of winds. As the low-pressure area and warm air continue to develop, winds from surrounding areas begin to converge towards the center of the storm. This convergence creates a spiraling motion, with winds moving counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Eye formation. As the hurricane intensifies, a well-defined eye forms at its center. This calm and clear area is surrounded by a ring of powerful thunderstorms known as the eye wall. The eye wall is where the strongest winds and heaviest rainfall occur. The main characteristics of a hurricane include strong winds. Hurricanes are known for their powerful winds, which can reach speeds of over 74 miles per hour, 119 kilometers per hour, and can sometimes exceed 150 miles per hour, 241 kilometers per hour, in the most intense storms. These strong winds can cause significant damage to buildings, trees, and infrastructure. Low pressure. Hurricanes are characterized by a low pressure center, also known as the eye of the storm. The air pressure at the center of a hurricane is significantly lower than its surroundings, creating a vacuum-like effect that draws in surrounding air. Eye and eye wall. The eye of a hurricane is a relatively calm and clear area at the center of the storm. It is surrounded by a ring of powerful thunderstorms known as the eye wall. The eye wall is where the strongest winds and heaviest rainfall occur in a hurricane. Spiral bands. Hurricanes typically have spiral bands of thunderstorms that extend outward from the center. These bands can stretch for hundreds of miles and bring heavy rain, gusty winds, and sometimes tornadoes. Size and shape. Hurricanes can vary in size, with some being relatively small in diameter, while others can be hundreds of miles wide. They often have a distinct spiral shape, with the most intense weather occurring near the center. Heavy rainfall. One of the defining characteristics of a hurricane is its ability to produce heavy rainfall. These torrential downpours can result in widespread flooding, causing significant damage to infrastructure and posing risks to human safety. Storm surge. Hurricanes can generate a storm surge, which is a rapid rise in sea level along the coast. This surge is caused by the strong onshore winds pushing water toward the land, leading to coastal flooding and erosion. Duration and movement. Hurricanes can last for several days or even weeks, although their intensity may fluctuate during that time. They are often on the move, traveling across vast distances at varying speeds. The path and movement of a hurricane are influenced by atmospheric conditions and other factors. Understanding these main characteristics of hurricanes is crucial for monitoring and predicting their behavior, enabling communities to take appropriate measures to protect lives and property in the path of these powerful storms. Hurricanes are classified into different categories based on the Saffir-Simpson hurricane wind scale, which measures their intensity and potential for damage. The scale takes into account the maximum sustained wind speed of the hurricane. The categories range from 1 to 5, with Category 5 being the most severe. Here is an overview of the different hurricane categories and their characteristics. Category 1, 74-95 miles per hour or 119 to 153 km per hour. Category 1 hurricanes have sustained winds between 74 and 95 miles per hour, 119 and 153 km per hour. They can cause some damage, including to trees, power lines, and small structures. However, their impact is generally considered to be minimal. Category 2, 96-110 miles per hour or 154 to 177 km per hour. Category 2 hurricanes have sustained winds between 96 and 110 miles per hour, 154 and 177 km per hour. They pose a moderate threat and can cause extensive damage, including to roofs, windows, and mobile homes. Flooding and power outages are also possible. Category 3, 111-129 miles per hour or 178 to 208 km per hour. Category 3 hurricanes have sustained winds between 111 and 129 miles per hour, 178 and 208 km per hour. They are considered major hurricanes and can cause significant damage. This includes destruction of well-built homes, uprooting of trees, and widespread power outages. Storm surge and inland flooding are also major concerns. Category 4, 130-156 miles per hour or 209 to 251 km per hour. Category 4 hurricanes have sustained winds between 130 and 156 miles per hour, 209 and 251 km per hour. They are classified as major hurricanes and can cause severe damage. This includes catastrophic damage to well-built homes, extensive power outages, and significant storm surge. Flooding can also be extensive. Category 5, 157 miles per hour or higher or 252 km per hour or higher. Category 5 hurricanes have sustained winds of 157 miles per hour, 252 km per hour, or higher. They are the most severe hurricanes and can cause catastrophic damage. This includes complete destruction of buildings, extensive power outages lasting weeks or months, and potentially life-threatening storm surge. Flooding can be widespread. It's important to note that while the Saffir-Simpson scale primarily focuses on wind speed, hurricanes can also cause significant rainfall, storm surge, and tornadoes, which can lead to additional damage and hazards. The intensity of a hurricane is typically measured using various meteorological parameters. The primary measurement used to assess the intensity of a hurricane is the maximum sustained wind speed. However, other factors such as central pressure and storm surge are also taken into consideration. Here are the main methods used to measure the intensity of a hurricane. Maximum sustained wind speed. The maximum sustained wind speed is the most widely recognized measure of a hurricane's intensity. It refers to the average wind speed sustained over a 1-minute period near the center of the storm. These wind speeds are measured by instruments such as anemometers on weather buoys, ships, and aircraft, as well as through remote sensing techniques like Doppler radar and satellite observations. Central pressure. The central pressure of a hurricane is another important indicator of its intensity. Lower central pressures generally correspond to stronger storms. This measurement is obtained using specialized instruments, including dropsondes released from aircraft that descend through the storm, or by analyzing data from weather buoys and satellites. Integrated kinetic energy, (IKE), is a measure of the total kinetic energy contained within a hurricane. It takes into account both the wind speed and the size of the storm. IKE provides a comprehensive assessment of a hurricane's intensity and is often used to compare storms of different sizes. Storm surge. While storm surge is not a direct measure of wind speed or pressure, it is a critical component of a hurricane's intensity. Storm surge refers to the abnormal rise in sea level caused by a hurricane's winds and low atmospheric pressure. The height and extent of the storm surge are measured using tide gauges, coastal sensors, and satellite observations. Hurricanes, also known as tropical cyclones or typhoons depending on the region, primarily occur in specific regions of the world where the necessary environmental conditions are present. The main regions where hurricanes occur include Atlantic Ocean, including the Caribbean Sea and Gulf of Mexico. The Atlantic hurricane season typically runs from June 1st to November 30th, with the peak activity occurring between August and October. Hurricanes in this region can impact coastal areas of the United States, Mexico, Central America, and the Caribbean islands. Eastern Pacific Ocean. The Eastern Pacific hurricane season aligns with the Atlantic hurricane season, running from May 15th to November 30th. This region is prone to hurricanes that can affect countries such as Mexico, the southwestern United States, and some Central American nations. Western Pacific Ocean. The Western Pacific is the most active basin for tropical cyclones, including typhoons. The typhoon season in this region is year-round, with the highest activity occurring between May and October. Countries like Japan, the Philippines, China, and Taiwan are frequently affected by typhoons originating in the Western Pacific. Indian Ocean. The northern Indian Ocean experiences tropical cyclones, referred to as cyclones, primarily during two seasons. The pre-monsoon season runs from April to June, and the post-monsoon season occurs from October to December. Countries such as India, Bangladesh, Myanmar, and Sri Lanka are susceptible to cyclone impacts. South Pacific and South Atlantic Ocean. The South Pacific and South Atlantic regions also witness tropical cyclone activity, although to a lesser extent compared to other basins. Cyclones in these regions can impact areas including Fiji, Vanuatu, New Caledonia, Australia, northern regions, and the coastal regions of Brazil. It's important to note that while these regions are the primary areas where hurricanes occur, their exact paths and intensities can vary from year to year due to various atmospheric and oceanic factors. Regional meteorological agencies and organizations monitor and provide forecasts for these regions to help communities prepare for and mitigate the impacts of hurricanes. Hurricanes can have significant impacts on coastal areas and communities. Here are some of the ways hurricanes can affect these regions. Strong winds. Hurricanes are characterized by powerful winds that can cause extensive damage to buildings, infrastructure, and vegetation. High-speed winds can uproot trees, tear off roofs, and damage power lines, leading to widespread power outages and disruptions to essential services. Heavy rainfall and flooding. Hurricanes often bring intense rainfall, resulting in widespread flooding. Heavy precipitation can overwhelm drainage systems and cause rivers, streams, and coastal areas to overflow. This can lead to flash floods, river flooding, and storm surge flooding, causing damage to homes, infrastructure, and posing risks to human safety. Storm surge. Storm surge is one of the most dangerous and destructive aspects of a hurricane. It refers to the abnormal rise in sea level caused by the hurricane's strong winds and low atmospheric pressure. Storm surge can result in coastal inundation, erosion, and destruction of coastal infrastructure. It poses significant risks to lives and properties along the coast. Coastal erosion. Hurricanes can erode beaches and shorelines due to the combination of high winds and storm surge. This erosion can lead to the loss of valuable coastal land, damage to structures near the coast, and changes in coastal ecosystems. Tornadoes. Within the outer bands of a hurricane, tornadoes can form, adding to the destructive potential of the storm. These tornadoes can cause additional damage to buildings and infrastructure. Displacement and evacuations. In the face of an approaching hurricane, communities may need to evacuate to safer areas. This can lead to the displacement of residents, temporary closure of businesses, and strain on emergency services and resources. Economic impacts. The destruction caused by hurricanes can have severe economic consequences. Coastal communities heavily reliant on tourism, fishing, and other industries may experience a significant downturn in economic activity. Rebuilding and recovery efforts can also place a strain on local and national budgets. Environmental impacts. Hurricanes can have both immediate and long-term environmental impacts. They can disrupt ecosystems, damage habitats, and lead to the release of pollutants into the environment. Coastal and marine life may be affected by changes in water quality, habitat loss, and the destruction of breeding grounds. It is essential for coastal communities to have robust emergency management plans in place, including evacuation procedures, early warning systems, and infrastructure designed to withstand hurricane impacts. These measures help minimize the risks and mitigate the impacts of hurricanes on coastal areas and communities. The path and intensity of a hurricane are influenced by a combination of various factors. These include sea surface temperature. Hurricanes require warm ocean waters of around 26 degrees Celsius, 79 degrees Fahrenheit, or higher to form and strengthen. Warmer waters provide the energy necessary for the storm's development and intensification. Atmospheric moisture. Moisture in the atmosphere is crucial for the formation and sustenance of hurricanes. High levels of humidity contribute to the instability and convective activity within the storm system. Atmospheric stability. Hurricanes thrive in an environment with unstable atmospheric conditions. Stable atmospheric conditions, characterized by a lack of vertical wind shear and a stable temperature profile, can inhibit the development and intensification of hurricanes. Coriolis effect. The Coriolis effect, caused by the Earth's rotation, influences the rotation and overall structure of a hurricane. It helps determine the direction of the storm's movement, with hurricanes in the northern hemisphere generally rotating counterclockwise and those in the southern hemisphere rotating clockwise. Atmospheric pressure. The pressure gradient within and around a hurricane plays a role in its movement. A lower pressure at the center of the storm compared to its surroundings causes air to flow inward, resulting in a cyclonic circulation. Upper-level winds. The strength and direction of winds at higher altitudes, known as upper-level winds, can impact the development and structure of a hurricane. Favorable upper-level winds that are weak and non-disruptive allow the storm to organize and intensify. Land interaction. When a hurricane encounters land, it can disrupt the storm's structure and cause it to weaken. Land areas can disrupt the inflow of warm, moist air and hinder the storm's access to its primary energy source, the warm ocean waters. Geographic features. The presence of geographic features, such as mountains and coastlines, can influence the path and intensity of a hurricane. These features can cause the storm to deviate from its original track or enhance localized effects such as heavy rainfall or storm surge. It's important to note that forecasting the precise path and intensity of a hurricane can be challenging due to the complex interplay of these factors. Meteorological organizations use sophisticated models and observational data to make predictions, but uncertainties remain, particularly in the long-term forecast. Continuous monitoring and analysis are crucial to provide accurate and timely information to populations in the potential path of a hurricane. Meteorologists track and predict the path of a hurricane using a combination of observational data, satellite imagery, weather models, and historical data. Here's an overview of the process. Observational data. Meteorologists gather data from various sources, including weather stations, buoys, ships, aircraft, and weather balloons. This data includes measurements of temperature, humidity, wind speed and direction, atmospheric pressure, and other relevant parameters. These observations help build a picture of the current conditions in and around the hurricane. Satellite imagery. Satellites provide valuable information about a hurricane's cloud patterns, structure, and movement. Advanced satellite systems equipped with specialized sensors track the storm's development, track, and intensity. This data is crucial in identifying the storm's location, eye formation, and the overall organization of the system. Weather models. Meteorologists use computer models that simulate the atmosphere to forecast the future path of the hurricane. These models take into account various data inputs, such as current weather conditions, atmospheric pressure patterns, and sea surface temperatures. By running multiple iterations of the models, meteorologists can generate different scenarios and predict the most likely track of the hurricane. Ensemble forecasting. Ensemble forecasting involves running multiple iterations of weather models with slight variations in initial conditions. This helps meteorologists assess the range of possible outcomes and gauge the uncertainty associated with the forecast. Ensemble forecasts provide a more comprehensive understanding of the potential paths a hurricane might take. Historical data and climatology. Meteorologists analyze historical hurricane data and climatological patterns to gain insights into the behavior of hurricanes in a specific region. This information helps in understanding the typical tracks, intensities, and preferred pathways of hurricanes in different seasons. Collaboration and expertise. Meteorological agencies and organizations collaborate and share information globally through networks such as the World Meteorological Organization, WMO. This cooperation allows for the exchange of data, expertise, and coordination in tracking and predicting hurricanes. It ensures that the most accurate and up-to-date information is available to forecasters. By combining and analyzing all of these data sources, meteorologists can track the movement, intensity, and potential impacts of a hurricane. As the storm progresses, forecasters continually update their predictions and issue advisories, watches, and warnings to help communities prepare and take necessary precautions. In conclusion, the formation of a hurricane is a complex process influenced by various environmental factors. From warm ocean waters and low atmospheric pressure to moisture, humidity, and the Coriolis effect, each component plays a crucial role in shaping these immense storm systems. Understanding the formation process allows meteorologists to track and predict hurricanes, providing communities with valuable time to prepare and mitigate potential damage. By staying informed and prepared, we can better safeguard ourselves and our communities in the face of these powerful natural phenomena. Thanks for watching. Please do not forget to like, share and subscribe to our channel for more videos like this. Please leave a comment below saying, "I subscribe." I will try my best to reach out to you personally and thank you for your support. That will be greatly appreciated.